Okay, this is another video about the pattern stimulation microscope, and we're going to discuss three things. One is the overlap of the two lasers, the 930 imaging laser and the 1030 photostimulation laser at the sample. The second thing we want to do is to just show how to do a axial point spread function for example, for spiral scan beams. And then the third thing is we want to show how to do a calibration of the coordinates of the SLM to the coordinates of the microscope, which is essentially the coordinates of the resonant galvo scanner. What I have is a dish, and at the bottom of the dish is some dye, and we're illuminating it now with some green light. The underneath is an inverted microscope, and this objective underneath is a 10x, and it's controlled, the focus is controlled by this stage. And then underneath we got some filters right here, and then a tube lens right here, and that goes back here to a FLIR camera. And the images from that FLIR camera are what we are going to take advantage of in this video. As I said, it's a diagnostic, it wouldn't be on a normal microscope. And then you can see that from the last time, if you saw the last video, we have plastic over what is the beam path area for the 1030 laser, and that's partly because there's a bit of wind, air currents that will make the beam fluctuate in the sample plane. To minimize that, we've just covered that path. And so what we're going to do at the moment is the laser is on, the shutter's closed, but the triggering is just internal at the moment, and so we'll take advantage of that, and then we'll switch over to scan image control over the laser. And then this is just the slightly out of focus right there. Okay, is the setup, and so I'm gonna stop recording this way, and I'm gonna start recording on the screen, and that's using some software that's very convenient that you can download for free, which is this OBS software, where that's the screen of this monitor, right? So I'll do that in a moment, and then we'll hit start recording, and then we're just gonna work off of this computer. But you see what's going on in terms of the hardware, so that's all straightforward. Okay, we are back, and we are looking at the surface at the moment with just exciting with green light and looking at the fluorescence of the surface. Okay, and what we're going to do is make sure the fan is off. Okay, it is. Okay, and so let's zoom in. Oop. And we're going to turn off the light, and we're going to put on the 930 laser. We're just going to use the point function, and this is going to be probably bright. So let's give that a try. Let's see if we can see it without, yeah, okay. Alright, so there is the beam, and it's a little bit off our cursor, but that's okay, it's going to wander around. And we can move the sample up a bit or down. That's down, and that's not good. Up. Up is a little better. And it's too much, so let's come down. And so it's a combination of good focus, but not the brightest, is right about there. And so that's probably about 3 pixel wide. One, two, a little 2.5 or so. And the pixel size is 6.5 microns, and the magnification is 22.22. Anyhow, it works out to about 0.3 microns. So we're 2.6 to 3.9, so somewhere in there for our full width half max lateral. Let's zoom that, and we can try tweaking that a little, or somewhere around there. Okay. All right, so that is the 930 beam. And for the moment, let me park that. And let's turn on, and I have to lean over to do this, the 1030 beam. So I'm just opening the shutter. Okay, and as you can see, that has wandered off a bit, and it's also not quite as small a spot size, so that may be that its focus is slightly different. So the two things I would like to do is to first just try different Z's. So that's where the 930 was optimum, and then so this is two microns different in Z. And okay, and then some amount of this beam could be jitter, either the reflection off of the SLM, or it could just be more of the residual air currents. And then the location I can change by just tilting one of the mirrors, that either the SLM reflecting surface, I could tilt that, or I can tilt an input mirror to the SLM, which is, we'll see, is this one. Now this, in my experience, doesn't happen very often, but if it does, it may or may not require a slight tweak of the alignment. Whoop. Okay, that's not quite right, but it's pretty close. And again, and let's just see, show phase mask, SLM phase mask. Okay, so that's a flat phase mask, so that's good. All right, so that's that beam. And if we want, we can measure the point spread function of this beam as well as the other beam. Let me stop that for the moment. And close that, and turn this over to internal, or not internal, but external triggering by the ScanImage program. So I'm on the screen that you can't actually see because we're not monitoring that screen. All right, and remember, to do work with the SLM, we end up working with and through the ROI group editor, and that's the principal work process. For example, let's see, a couple of things. One is, let's abort this. And what is the parked position of this SLM is way off, away from zero. And that's a real, like, the beam is really being steered. That's just the park position, and it's something that can change, and it's not to be confused with the zero position. So you can right-click on this screen, and you can park the beam. You can just press zero. Zero location is noted by this, which is essentially a flat phase mask where the small phase difference is offsetting a slight deformation of the sensor surface to make it flat. Okay, and then other things you could do is you could add or remove points, and then you can move this. Okay, so that is something that we'll keep a monitor, but we really don't take advantage. We'll just keep an eye on this phase mask. All right, so we looked at the overlap of the two beams, and to go back to this, I've set this up where this is just a point, and let's go 0.8. 2, and this would be for about 6 seconds, and that's all that does, right? This stuff here, kind of repetitions and revolutions, that refers to the galvo. Remember, the way we're set up is the SLM is followed by the galvo scanner. So the SLM just gives you the multiplicity of points at different locations, but it is the galvo scanner which will put a spiral on each one of those. Okay, so we can do start and then double click on this, and this should not have changed because we're going for 0. And then if we try this, that's running, and so what we want to do is hit trigger. Okay, so there is again this beam, and let's get it, and then one more time I can try here. There are 2 ways I can do this. One is to, I won't do that. Actually, I don't know why that was off, but that's a better place for it to be. So this is always, in my experience, what has to be done. So I'm just adjusting Z. Okay, so that's about the minimum. And then let me go to a new spot, because I think part of that is yeah, and so we're still not quite there. Yeah. Okay. All right, that is the 1030 beam without any kind of a pattern. So I want to change now. Let's abort this. And I want to do a spiral scan. So this is the second thing that we wanted to do. Spiral scan, and then take a Z profile of those beams. So let's load a group, and I've been using just this simple 3-point alignment. Alright, and let's put this on here. We're going to go for really long repetition, and I'll tell you why. Second thing we need to do is we're going to be using this FLIR camera. So that was this window right here, and it's got 2 modes, and one is a Z-stack mode and one is a live mode. And at the moment, let's put the okay. Remember, this is a camera that is going through a different optical path than the other camera. I'm going to turn this down to about 13, and I'll turn this up to about 2, and we can zoom in, and the focus doesn't look terrible, but let's see if we can't make that a little bit better, because we want to use this camera okay. I think that's okay. We want to use this camera for doing a Z-stack, where the image is taken from this camera, and so let's abort that. And if things work out, we should use about 50 milliseconds for doing the points. Okay, so we're here. We have this point set up. We have the duration 2 milliseconds, and we're going to do repetitions. So this is log spiral that's been modified by us to have a more uniform profile. Beam power is 2%. The way to do this now is to enable stack, and this is not the default, but it is what I used the last time, and it is what I want to use now. So I'd like to break this up. These point spreads functions are expected to be on the order of 10 microns, and so we might want to go 3 times that above and below. This might be a little excessive, but anyhow, that's what we'll do. And the step size is going to be 1 micron per slice. So we'll have 60 images, or 61 images, because we're going to include the center image. And so this is a centered stack. And we're going to use, there are typically 2 choices, and the default is Moda, but you want to use Fast C, and click to return home. Alright, so I don't really need this window because we know what we've set up. And while I don't need necessarily this, it is nice to watch what's going on. And the same thing is true here. So I'm gonna put that out like that. Alright, and now the way I've set this up again is that in the ROI, this is going to run 2 milliseconds per log spiral, and then we're going to repeat that 30,000 times. So that's roughly 60 seconds. And based on experience, I know each one of the slices takes about 3/4 of a second to process, to take and process, even though the exposure is 50 milliseconds. So that to do 60 is going to take 50 seconds, 45 seconds. Anyhow, I'm running the ROI this guy for 60 seconds. That gives us plenty of time to take the stack. Seems maybe a little bit complicated, but it's not too bad. Alright, so the one last thing that we need to do is to save. And let's put it in today's directory. And let's do select, and let's call this stack 1. Okay, and so the one last thing is we had this set up for rolling average, and I would like to put that back to 1. So that we don't have any carryover from one frame to the next, so we can get a more accurate value. Okay, so we have enabled the stack. We've set up the stack controls. We're only going to get 1 frame, no averaging. We're going to click this, and this will bring up that 3-point pattern. Going to double click that, and then as soon as I hit trigger, I want to come over to here and click Start Z-Stack. So let's do that. And when I click trigger, you're going to see the pattern on the Neo camera. That's this guy here. And then as soon as the stack begins, it will go to plus 30 and you'll lose that. So let's go to trigger. Okay. And that unfortunately might be okay. It doesn't matter. So let's start the Z-Stack. And you'll see spots starting to appear as we get the scan goes close through 1. Yeah, I must have zoomed in. Okay, it's gone back to 0, and now it's done. And what we didn't necessarily do So bear with me a moment. Live. Okay. There. Okay. Abort. And let me turn this off. And I wanted to show you that again. So let's just repeat this. So we're going to hit trigger. This will automatically index itself to the next acquisition. Hit trigger. That's there. And then we're going to do start ZStack. Okay, and then, well, this is the one in the center is the zero order beam. And then what we'll have to do is ask whether we've exceeded the saturation of the camera below. And if so, then this number shouldn't have been 50, it should have been something less. And the way we're going to find that out is, let's abort this. Let's turn this off. And let's open up ImageJ. Okay. And we sent this to show you stack 1, stack 2. Let's look at stack 2. Okay. Yeah, it's a little odd that the first one, but the first one has always got some residual image in it. Okay, what we have is 255, so that's really saturated. 255. So I think we need to redo this with, I can look through this. While it should be a top hat, this is probably going to be, yeah, so clearly saturated. The way to handle that is to take this down factor of 10. Let's go factor of 5. Okay, and we're going to just repeat this. Start. Remember, that is all that's doing is sending the phase to the SLM, which is the phase for these 3 points. And then I'm going to double click this stimulus group. Okay, and then we don't really need this. It's going to run for a little, about 60 seconds. This will take about 45. So let's do trigger. And then let's click OK. And as I've said before, when this gets close to 0, we should start seeing the points come up. This is also occurring and done. Okay. All right. This has been written to, so this will be the next incremented file. That's 3. Okay, and then we can zoom through this, and then we can see what these, let's do this. And go to stacks and go plot the z-axis. Okay, never goes up to 255. Individual pixels might, but unlikely. And that would be our Z axial profile. And so if it's 60, looks like 60, almost 70, so 35, so maybe somewhere around here. And that cursor, if you look up on the, up here, the cursor reading is about 27.4. And then here, about 34.2, so 27 to 34 sounds like 7 slices, and there's 1 micron per slice. So that suggests that the axial point spread function for this spot is 7 microns. And then we could do that for the others. I clicked the live button on this, so this just moved it to this one, and then we could ask 48, a little above that. What's this? Whoop. What this is, and that's 29, and that's 37/4, 7.5. So that's about 7.5 microns, and then the other one, we put it on there, and then yeah, okay. Not too sensitive. My understanding is it's not too sensitive to, and that's this, and then that is also 60, say 68. So we're somewhere around here. It's 29.4. Yeah, so that's 7 microns. All right, so if I did this right, here is step size per micron, and so that's 7.5. So in this plane, each of these is about 7 microns. And then the other thing to look at is ask, are they all peaking in the same plane? And the way we can do that is, let's go to the peak of this one. That I'm just moving which frame we're looking at, and then okay, so that's that. Let me blow this up because I don't have to change anything. Okay, and then okay, and so that's peaking in the same plane, and this one up here is peaking slightly before, so the focus for this one up here is a little bit off. And this one here is a lot off. This is the center zero order beam. Normally that would be blocked. We don't block it. We don't need to. And so anyhow, so that's something to look for, that you might have an offset, and so you might intentionally, you could map this out across the field of view, and you might intentionally change the position. So we could do that by going to points, and then you could put in different values for Z. Now that has been true in the past, but recently I think after some work that was done, these are not functional at the moment, so I don't want to show you something that's not going to work. So I'll just say in principle that's how you do it. And in fact, you can also weight how much light goes to each one of these points. So if one of these was dimmer than the others, you could double that weight or some amount. All right. There is no reason that this wouldn't be couldn't be tricked into just doing beam profile for either rather than log spiral, we do just a point. And so this might give us the point spread function at different locations. It will ignore this, and it will have a duration and a repetition. The beam power is probably too high, so I'm going to drop that to 1. And this shouldn't matter. This is talking to the size determined by the scanner. So let's repeat this now. I'm going to let this go and this go. I'm going to abort. Anytime we change something in here, we have to abort and restart. And okay, we double click and we're waiting for a trigger, and then we're going to start Z. Let's see how this goes. Trigger and then start Z. Okay, there are spots. Okay, this is done. This is not done, and you would know it's done by it's waiting for trigger. It got the trigger, it's going through its process, and then it'll say, we'll see. That's supposed to be the way it works. Okay, so that's output, and that was fine. And then this will be number 4. I can open this up. Okay, unfortunately, I think we're going to be still too bright. Okay. Now, one of the things that you see, I see, is this angle of the beam axis, and so it is coming in slightly at an angle, and maybe that makes sense because it's off to in space. It's going off to a location in the periphery of the field of view. So if that were the issue, let's zoom out, and it should not be true here. And so we can now go through this, but we still have a little bit of a difference in the location. So it's not a 100% optically clean system. The brightness auto, ooh, yeah, okay, 255. Okay, and that's saturated. That should be obvious. Okay, it's not terribly saturated, but this is the lateral full width half max, so we're going in pixels roughly from 21.5 to 24.8, so it's about 3, a little over 3. And again, this camera, the conversion is about 0.35 microns per slice. I'm sorry, per pixel, not per slice. Again, this is on the order of about 1 micron. Alright, so that's what that is, and that's that. And I'm going to close this now and close that. And we've done stack controls, or at least really rudimentary example of that. And the next thing we're going to do is to worry about getting the calibration right. Okay, that'll be next. All right, what I would like to do for doing this alignment is to burn holes into a dye film and to then compare where we expected to fire those holes and what we actually got. And so let me show you that. So let me load a group, and this is going to be the three-point burn pattern. So it looks familiar. And okay, and then the way this is set up is, let's click on this, and so we're using a beam power of 4%. Okay, so previously we were using 2%, which didn't burn, and 4%, which now will burn. Using log spiral, that's okay. We're taking the size to be rather small, 1 micron by 1 micron bounding box, 2 milliseconds at B4. The process that we want to go through is to, let's go over to focus. So the primary dichroic is in, and we should have a power of 2%. Okay, and so here are the two channels. Okay, and then I've got one of those channels. It looks like I got channel 2 being displayed in the ROI group editor. And I guess if we wanted to make it look a little better, that's okay. There we go. All right, now to do this, what we want to do is turn this off and definitely protect the PMTs from the intense 1040 light. In a real experiment that might not be possible, but at least for now that's what we're going to do. So we'll start this. Okay, so the pattern's at the grading, double click that. So we're just waiting for a trigger. What I'm going to do is bring in the bottom camera. Let me change this to 50. It won't matter for this. We're not going to capture this in brightness. But this is just a monitor of what we're doing. And so when I hit trigger, we're going to see a burn pattern or a lot of light, which will indicate the burn pattern. So let me do that. And trigger. Okay, I just did that twice, and let's do focus. Ooh, there's always the question of whether the laser is on. The laser's on, but the shutter is closed. So I'm over at the laser, and we've just done that. So we've turned that on, and here we go. Trigger. We blew out one of these. So we do this and turn it on, and then you can see the 3 spots that got burned. All right, and if that's a little confusing, let's do that, because that top one actually didn't get burned. And let's monitor this again, but turn this off, and let's abort, start. Double click and trigger. Okay. And then let's go focus. All right. Here are the burn spots, these dark spots, and this green star is where we were supposed to be hitting it. So it looks like our calibration is off. Certainly could be. And so the way that we would do this now is to open up, go to View, go to Alignment Controls. Okay, we're going to copy in channel 1. Let's show alignment window. And this says SLM points, but for the moment, let's just clear it by putting in photo stimulation and then SLM points. Okay. And a couple other things, just reset view and then reset transform, and then let's zoom in on this. All right, the idea, I can turn this off for the moment. The idea is that we're going to take each one of these, and I'll take that there, and I'll pin it. And I'll take this one here, and I'll pin it there. Okay, and then I'll pin this one here, and fix that. Alright, so it went from magenta to red, and red indicates that these points are the fixed points, right? I could clear those, I could add another point, and so forth. Alright, let's then save scanner alignment transform. Okay, so I'm going to continue. And what happens is this goes back to what was something similar to the original alignment transform. So we just want to move on and reproduce this. So let's move our sample up a bit. Yep, there it is. And so we would go like that. All right, and so then we want to abort. And we'll abort this just for... We actually have to because we've changed the pattern, the alignment for the SLM. This is a transform that gets written to the SLM when we define some points and click Start. Double click on this. Okay, and then trigger. Okay, and then we can go back to focus. Okay, so that now looks pretty good on this ROI editor, and to see that here, we want to copy channel 1, and then what we want is to go to photo stim, then we go back to SLM, and we can reset the transform, we can reset the view, we can do all these things to make sure that everything is cleared. And now that is really quite good. You might say this point over here is off a bit, and in my experience that's an acceptable, at least at the moment. If this SLM alignment algorithm for taking 3 points to create a affine transform is improved, then that would be something that would be useful. Alright, I think I want to just show you what that looks like, and let me call up MATLAB. Okay, and let's just do this. Okay, and so this is the current transform, And I can tell you from long ago, this here was an earlier transform that worked fairly well also, or at least I'd have to see back how far I have to go. Yeah, maybe that went back to here. So you got -2's off diagonal, 0.8 minus plus, and then essentially 1 and 1.5. And then now we have -2's on the off diagonal, minus plus 0.8, and then 1, and then, but this offset, this is a y offset, is this number here. That's what it is, and that works pretty well, and that's the burn pattern that we get. We could have made this a little better by taking more points, or taking the points at different distances from the origin. There might be a way to incorporate the information about the location of the origin, which is where this guy is. And okay. All right, I think that's it for doing this sort of simple alignment of the SLM coordinates to at least get it very close to the resonant Galvo coordinates. I'm going to stop at the moment and stop this, and then I will stop recording.